Hello everyone, this is my third assignment from Intro to CS, and let's start from the problem 5. So I wrote this code function binary sum AB. So I wrote define some R1 is array, R2 is second array, if A is equal to 0. So we write R1 that unshift. So basically it's a special case, and we write R1 data shift to add missing items from the left. So else, while it's not equal to 0, we write R1 data shift A divided to 10. So we add the number divided to 10, the remainder. We add the remainder from the left. And A math floor A divided to 10. Also, we add um, this uh, that number also from the left. So it will be our way. So we write the same code from the B, so we don't need further explanations. And now we have two cases when R1, so the length of R1 is bigger than uh, R2, length of R2, and of course the opposite. So uh, let's look for this code. So if the length of R1 is bigger than length of R2, we define such L, that is the difference length of R1 and R2. And for that is equal to 0 is less than L, A plus plus, and we write R2 to downshift to add missing items from the left. Also, we write the same stuff for the opposite case, as I said before. Now, that sum is equal our array, so it will actually be our final array. So and now we define such carry, let carry is equal to 0, and let t is equal to 0. I will explain the meaning of the t further. And now let our L is R1 length minus 1, or let e is equal to 0 is less than the length of R1, e plus plus. So our t is equal R L minus e plus R2 L minus e plus carry. That is because we have many cases such that, for example, t can be 0, t can be 1, t can be 2, t can be 3. So t is the value, the last value from the array. So I will explain more. If t is equal to 0, we unshift. The case could be, 0, 0 will cause 0. So this is our first case. Else if t is equal to 1, we unshift and carry is equal to 0, because 1 and 0 will be 1, and the carry, of course, will be 0. Then else if t is equal to 2, we write sum and shift carry equal to 1, because 1, 1, we will write 0, and the carry will be the next one that we will carry in mind this one and add um, the that case. So and t can be 3, and we write sum that unshift and carry is equal to 1 again, because it can be case like 1, 1, 1, and also 1, 1, 1, 1. So 1 plus 1 will be 2, and we will write 0. And on the other case, we will have 1 plus 1, but we also have carry, so it will be 2 plus 1, 3. So we will write 1, the carry will be 1. So and if carry is equal to 1, we write sum or shift and return sum. So constant log binary sum is 0, b, row 101. So we write node 1.js, and the second one will be string 101. So that's correct. So let's go to problem 6, create a function that inverts and returns a given binary number. So we write function binary inverse, let string var a to string. This function converts a number to a string. So the let inverse var is equal to string for let is equal to 0 is less than the length of string var e plus plus inverse var plus string var dot chart e equal 0 question mark 1 and 0. So in this line we explain that um, that if it is 0, it will print at 1. It will add 1, and else if it is 1, we will add 0. So return inverse var. The constant log binary inverse this number, and it will be inverse. So if it is 1, 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, it will be the vice versa of that number. So the seventh question was create function that converts a given number in binary number into two's complement. So function binary two's complement bin number. The inverse is equal parse int binary inverse bin number. Parse, yes, I think it's clear that and let final result is equal binary sum inverse 1. So it will be our two's complement inverse plus 1. So return final result that join strings to get rid of from the strings. And the final result constant complement is two's binary two's complement 0, 1, 1. It will be complement is 1. So let's move to our first problem. Create function that takes number as its arguments and returns true if the number is a prime number and false otherwise. The function test prime n if n is equal to 1, return false. Let's select prime number, else if n is equal to 2, return true because it's prime. Else for let x is equal to 2, x less than the mass squared n x plus plus. If n divided x is equal to 0, we return false because it will not be a prime. Else if return true. So we don't need to write else if. And then constant log test prime n 37. 37 is a prime number, so it will be true. The second problem was create function that takes two numbers as its arguments and returns an array that contains all the prime numbers between them intercepted. A function test 2 let r string let for let e is equal to a, e is less than b, e plus plus. If test prime e, so we push e. Return r join to get rid of from strings console log 2, 1, 7 into print 2, 3, 5, 7. The push function actually adds missing elements from the right. Functions here. In the third problem, create function that returns the reverse number of a given number. Function test n let t will be our array while n is bigger than 0. We write t that push n divides 10 and n math or n divides 10. Actually, it is it is almost the same problem as the fifth question, so we don't need further explanation. Return t join to get rid of strings. As I said earlier, console log task 3 and for example how handwritten it will print 001, vice versa. Also, the final question, create function that checks if a number is a palindrome by calling the function from question 3. Yeah, we write function check palindrome num if num is equal to number from task 3, return true, else return false. Plus log. So the number from task 3 was 100, so it printed false because it is not palindrome. So 100 and 001 is not closed. But if we write 121, this palindrome because it is the same number on the both sides. Yeah. That's all. Mm, that's all. Goodbye.